Hello, friends. Thank you for joining me today. My name is Leland Warnack, and I'm excited to do a cool experiment with you today. To start out, I want to let you know the fourth grade GSE standard we will be working with today. It is GSE Science Standard S4P1 Part C, and it says, plan and carry out an investigation utilizing everyday materials to explore examples of when light is refracted. Our learning target for today is I can use everyday materials to explore how light is refracted. So our big question today is, what will happen to the appearance of a pencil when we place it into a glass of water? Are you ready to get started? Me too. Take a minute and think. Have you ever seen a log sticking out of a pond or lake and it didn't look exactly straight? Or maybe you have stuck your arm in a pool, a bathtub, or another body of water and your arm looked funny or crooked. Maybe you've tried to catch a fish or pick up a rock in shallow water and you had trouble finding it with your hand, even though you're looking right at it through the water. Well, our experiment today will help us learn about this together. This experiment is super fun, super easy, and you can do it at home. You will need a glass or container that you can see through, a pencil, and water. That's it. So first, fill the glass almost to the top with water and set it on your work surface. Now, before you place your pencil in your water, pause the video and make a prediction. What do you think will happen to the pencil when you place it in the water? Got your prediction? Great. Okay, go ahead and place your pencil into the water. What do you see? Does the pencil look broken? Okay, what do you think will happen when I turn the glass? Pause the video and make a prediction. Got your prediction? Great. So watch the pencil as I turn the glass. It goes from looking broken to looking intact again. Well, watch as I turn the glass again. Pencil looks broken again. I promise you it's not. See? Still one piece. Neat, huh? So when you place the pencil into the water, it just looks broken. Why do you think that is? Do you think it's a trick pencil or a rubber one? Nope, just a plain wooden number 2 pencil, and it's just plain water in the glass, and there's no smoke or mirrors here. So why does the pencil look broken in the water? Pause the video and come up with your own conclusion. Got it? Great. Here's the answer. The pencil appears broken because of how light passes through the water. The pencil appears broken because the light passes through the water differently than the air, and it's called refraction. Water is denser than air. So when light passes from one transparent surface to another, in this case from the air to the denser water, the light slows down and bends. Remember, the pencil doesn't bend, the light does. Nothing actually changes. Just how we see the pencil changes. This is the same idea as when you look through a small object through a magnifying glass. It's how the light travels. This The object stays small, but it looks bigger because you're looking at it through the magnifying glass. It's how the light travels through the glass, just like how light travels through the water in our own experiment. So was your conclusion the same as what I just explained? If not, that is A-OK. That's just part of learning science. So remember, our learning target was I can use everyday materials to explore how light is refracted. That's what we did. We used everyday materials, a glass, a pencil, and water, to explore how light was refracted. The refracted light made the pencil appear broken. Great job, my friends. So stop and think a minute. What surprised you about this experiment? This experiment, my friends, is an example of a discrepant event. A discrepant event is an event with a surprising or unusual outcome. In other words, the outcome is different than what one might expect. If you have ever seen a pencil placed into a glass of water before, you may not think it would appear broken. Another great discrepant event would be how a metal needle will float on water when it's placed there very carefully. This is because of the surface tension of the water. Most people would probably think it would sink because it's metal, but in fact it floats, and that is the surprising outcome, just like the broken pencil was our surprising outcome. Teachers want to use discrepant events to help students think about their own beliefs. Are these beliefs valid, or are they just based on prior experiences or information? Using discrepant events helps spark curiosity in students and prompt them to ask questions. This also helps promote problem solving and critical thinking. Students become inquirers, and they learn to seek explanations for events and beliefs. Discrepant events also help address misconceptions students may have regarding science and related phenomena. I would use this same discrepant event in this video to help my students learn about refraction. And it goes well with GSE standard S4P1 Part C. And it said, plan and carry out an investigation utilizing everyday materials to explore examples of when light is refracted, which is exactly what we did. This experiment is a fun and easy way to get students thinking about refraction and the idea of things are not always what they seem. And it also adds a neat real-world connection, since it's something they can do easily at home, show their friends, show their parents. So it adds some more engagement to the activity. It makes it really fun for students. Hopefully my students will be inspired to seek higher understanding, and they will question similar things. Science is about doing and asking questions, and I believe discrepant events like this one are a great way to facilitate these things. I hope you've enjoyed my video, my friends, and I hope you have a great day. Goodbye.